Hi everyone. Hi, it's Mr. Morrissey. Let me know what song you think that just was. Everyone, if you want to start the next minute or so, if you want to take some deep breaths, some deep cleansing breaths to get ready for our last set of notes here on quadratics, writing equations of quadratics, a few word problems, but we'll be writing, let's see, our objective is to write the equations of quadratics in vertex, standard, or intercept form. We have practiced these three forms a lot, and I think we're ready to go. So I'm thinking you're going to read over the notes here, but basically it looks like we're just taking the three different kinds of equation, different forms of quadratics, and probably given some points and solving. So let's just work on that right now. Let's start with what I think is the toughest for students, which is the standard form. And so standard form says write quadratic function in standard form that passes through these 3 points. Let's notice we're given the y-intercept. Okay, so we know standard form BC. Oh, that's where I went to college. You know, I even had someone ask me today in class toward the end of the unit what a constant term was. So just making sure everyone understands this. We have the quadratic term. We have the linear term with our little friend, invisible 1. And we have the constant term. Okay? So there's our whatchamacallit, there's our equation in standard form, and we're going to know that the y-intercept is 4. So if I plug in, if I'm using now 0, 4 real quick, I'm going to get it would seem like all the zeros cancel out and we get c is 4. So we know automatically c is 4. And so let's use that information to our benefit. So let's start over. Okay. So now we'll take the second point, which was -1, -3. Let's start out with the harder point. We'll start out with the negative. So we're starting with -1, -3. Let's plug in. And this is going to give us an equation with a's and b's. Subtracting that 4, we get a minus b is equal to 7. Then if we use the second point, 2, 6, let's use 2, 6 in the same equation. So we get 2 equals 4a plus 2b, but if you notice, guys, all 3 of the coefficients can be divided by 2, or evenly divided here. So let's simplify our life as much as possible. So here are our 2 equations in terms of a and b. Let's pause there. So let's write ourselves a note. This is now a system. So we have a system. Let's line them up. Okay, so there's our system. It looks like if we just add the 2 equations together, we get a is -2. So we have a, we have c, so let's just find out b. So now we got to find b. So let's go back to our list. We had 2 comma 6. Why don't we use 2 comma 6? Oh, actually, what am I doing? We can figure out B just by using the, oh, I'm not thinking today. If we know A is -2, let's plug A into, here, so I'm going to erase this. Way too much. If we know A is -2, it looks like B looks like 5. So our final answer, guys, it's going to be this. There's a quadratic in standard form that passes through the 3 points that were given. -2x squared plus 5x plus 4. Let's just test one of the points, since it's always a good habit to be in to test your work. So let's test let's test the negative answer. Okay? So here's our test. So a lot of, we don't want to shy away from problems that we're scared of. So here I just plugged in -1. So let's make sure this is true. So does negative, I'll put a little question mark above this. So -3, this is, whoops, did I screw up somewhere? Oh yeah, this is -7. Sorry guys. So check, it works. So the answer that I'm about to put stars next to, totally the right answer. Okay, I think that's the hardest one of the vertex standard and intercept form. The next two we're going to go by quickly. Remember, you can pause and rewind anytime you want. I think that's one of the best features of these videos. Write an equation of a quadratic with roots of 3 and 7. Okay. So here is our friend, Mr. Morrissey's favorite. If you go back and read the notes, which I'm assuming everyone's reading, there's Mr. Morrissey's friend. This little a here is the coefficient. I'm really working to write this as neat as I can. Well, here are your roots. Almost done. If you, if you didn't have the second point or the third point, 6 comma -9, then you'd have an answer with an a in it. But since they tell you 6 comma -9, we can use that information. So when we plug in, sorry guys, when we simplify, we get, we can see the negatives cancel. So 3 is equal to A. So our final answer for what the equation is in intercept form is this. And if you wanted to check your work, which is a great idea, make sure that 6, 9 works. So let's make sure that 6, I don't think it's 6, 9, it's 6 -9. So -9 equals, does that work? And I know it does because we just showed this. Does -9 equal 3 times 3 times -1? Looks good to me. Keep going. Question 3. So write an equation of a quadratic with the vertex. Ooh, vertex form. I think people are scared of vertex form. There's vertex form. Well, the vertex is easy to throw in. So there it is, right? If you want to put it in the proper form, I mean, as the equation looks with a minus and a plus, but I want to clean this up a little bit. So I'm going to write it how you'd usually find it. That looks a little bit better. So there's a quadratic that's been shifted 1 unit to the left and down 4 units. And now we're just going to use this second point. So there we go. And now we're going to solve for A. So it looks like A is 1/3. So once you have A, guys, you're done. All we have to do, I'm going to put it in black here, is write the equation out. Let's see, x plus 1. Does that make sense? There we go. There's our answer. Let's use our friend the highlighter. Let's see. Ooh, you guys sometimes like it when I have the psychedelic. I know people always comment on that. So here we go. 1/3 x plus 1 squared minus 4. Okay, guys. You guys probably need a break. 11 minutes. Let's go back to that song. See if you can hear this. Ready? You guys know that song? I'll tell you who it is now. It's Michael Bublé, Home. Sort of like that song. Let's keep going. Physics. Okay, let's see if we can figure this problem out. So the laws of motion imply that the height of an object traveling at a velocity of, I don't know, v sub 0, or some initial velocity at any time t is greater than or equal to 0. So let's see. Whoa. Okay, let's leave the happy face there because we're going to hopefully this is going to be a happy face kind of problem. Okay? So we're looking for, this is t on the x-axis and height on the vertical axis. And it says the height is given by negative 16t squared plus the velocity times t plus h sub 0. Oh God, if a rocket loaded with Katy Perry brand fireworks is to be shot, oh, I'm so funny, is to be shot up vertically from the ground with an initial velocity of 160 feet per second, and the fireworks are to be detonated at the height of 384 feet while they're still on the rise, how long will it take, no, how long after the takeoff should the detonation occur? Okay, so let's see, a couple of things we know. Um, this thing is being shot from the ground. So the h sub 0, this is equal to 0. So height, the velocity is 160 feet per second, and the initial height is 0. So h sub 0 is the initial height. So this is being shot from the ground. Okay, and I do like the song Firework by Katy Perry. So does my daughter. So there is my starting equation, and it wants us to graph that, but it wants us also to figure out at what time will the fireworks hit 384 feet while still on the rise. So like, look, if I here factor out a t, or say a negative t, okay, here is my here's my graph. I know the graph is going to go through the origin. So, okay, there's my graph, and I want to know, I don't want to know what say the x-intercepts are or the second x-intercept, but it looks like it's 10. What I want to know is where, if I draw in a horizontal line at 384, is it feet, where is it going to touch right here? Because the firework is still, going up. What does it say? Well, it's still on the rise. So I want to go right here. I want to know what that point is. So this is just an intersection of two lines, guys. A parabola and this line at 384 feet. So I actually want to know if the height is 384, which if you notice, that's right there, h, when 384 equals this. And all I'm going to do is solve that quadratic, and I'm going to get, hopefully I should get two answers, because it looks like I'm intersecting that graph in two different places. So Let's do this. There's my quadratic by getting all the terms to one side. So let's factor. I'd pull out a calculator, and you're going to see that 384 is divisible by 16. So you get, oh yeah, I left off something. Yeah, the t, this is 100, you see here? I was going to say, this isn't going to work. So this is 160t. So this is minus 10t. And then that is 24. Great TV show. So I just want to find the intersection points, or sorry, now I want to solve this new quadratic, t squared minus 10t plus 24. The 16 doesn't matter because all I'm doing is solving for, in this case, what's going to be the x-intercepts of this new equation. This is going to conveniently factor. So 24 is, is that going to be 6 and 4? Oh yeah, 6 plus 4 is 10. So here we go, xx, put in my skeleton that so many students that talk about, which I think is great. So there's 6 and 4. Negative 4 times negative 6 is 24. Negative 4 plus negative 6 is negative 10. So x is 4 seconds. X is 6 seconds. And we want to know when the graph is, or when the Katy Perry brand fireworks. Great. If you haven't seen Part of Me, it's a decent movie. I think it's rated PG-13. That's going to be right here, 4 seconds. So like down here on the graph, that's 4 seconds in terms of the time. Okay. Thinking you guys do stuff like that in physics, but okay. Just keep in mind, if you want to find the intersection of two lines, or a quadratic in a line, or a circle in a line, you set the equations equal to each other. Last one. Let me just see if I can get this set up. I might have to take a break, because lunch duty is calling me. But if I have a hypotenuse and the legs differ by 1 inch, so here's leg 1, leg 2, and the hypotenuse is 1 inch longer than the longest leg. Well, that's x plus 2, right? Determine the side lengths of the triangle. Okay, Pythagorean theorem is something you would have done in past classes, and that's going to be x squared, x plus 1 squared equals x plus 2 squared. Don't start trying to guess and check on what the answer is. It is actually 3, 4, 5. The final answer will be a 3, 4, 5 triangle, but I don't want you guessing like that. So let's see. Let's expand out this quadratic. There's the left-hand side. Don't forget those middle terms. Okay, do not forget those middle terms. There's my bell. Okay, I gotta come back. I wonder if I can finish this. You're gonna notice here. Oh gosh. Where did I go? Let's see if I can finish this. Okay, let me see if I can finish this. So 2x squared plus 2x plus 1, x squared plus 4x plus 4. So when I combine here, I get x squared on the left-hand side minus 2x minus 3 is 0. Factor. We got 3 minutes passing time. 3 has got to be 3 and 1. So minus plus x is 3. Ignore x is equal to negative 1 because you can't have a negative one side triangle, although some kids try to talk about four-dimensional something. Anyway, so there you go. You get 3, you get 4, you get 5. So it's a 3, 4, 5 triangle. Sorry guys, that was a little rushed, but I'm going to have X block coming in after this. So this was a pretty intense lesson, and thanks for listening. Have a great day. Bye.